Aristotle, born June 19th, 384 BCE in Stygia, Greece, was a Greek philosopher and polymath, someone who harbors a wide range of knowledge. During his lifetime, Aristotle contributed to many fields of science and knowledge, including biology, astrology, and ethics. Some of his biggest contributions, however, come from his studies in physics. Aristotle had many theories on concepts that had no hope of being defined until centuries later, like gravity and the Earth's shape. Mostly, his theories on physics are about moving and changing things and theorizing about them, not physics in the modern, more mathematical sense. While he didn't have the fancy tools his successors would create, Aristotle's keen observations greatly contributed to the field of physics, especially in studies conducted across the next 2 millennia.
Okay, here we go. Natural philosophy. Aristotle defined science as either practical, poetical, or theoretical. Natural philosophy is the theoretical portion of his belief. It is one of the most important building blocks of Aristotle's theories on physics because he felt the need to circle everything back to nature and the 4 main elements, or 5 if you count ether. So let's get into that. The 4 main elements are earth, water, air, and fire. Cool, sweet, we know this. Then there's this outlying 5th element, ether. Some people say ether, some people say aether. If you say aether, you're just wrong. Anyway, ether, according to Aristotle, is the greater and lesser lights of heaven. Pretty celestial stuff. Ether, unlike the 4 main elements, can't mix and change. Fire, earth, air, and water can generate and be destroyed, mold together, and transform. Ether can't. Aristotle concluded that ether must be its own element because it can't be made of the natural elements that are capable of change. This idea is one of the earliest theories of phase transition. Oddly enough, ether contradicts Aristotle's ideas on physics, because I guess he really did want to study everything, even if he couldn't always be right or certain. So ether is a special snowflake. Cool. Now, let's talk about more Earth stuff.
The Earth. Aristotle believed the Earth was round and small. Believe that. If we have any flat earthers watching, trigger warning. We will discuss how the Earth really is round and how you are wrong. Anyway, Aristotle was in Egypt at some point, then in Cyprus, that tiny island near Turkey that's actually been independent for 60 years. He noted how the stars that he saw in Egypt and the tiny island were like the ones in Greece, so he concluded that the Earth was, in fact, a round girl. He also tied it back to the elements. The element of Earth has its natural place at its center, just like water moves toward the round bodies of water near it, or like smoke would move toward a round atmosphere. Another, less theoretical, sciencey sounding explanation is that Aristotle observed how the shadow the Earth casts on the moon during an eclipse is round. When the best tool you have is your eyesight, you can't rely on your elemental theories to carry your ideas. Appeal to things other people know and see. That's how things went in the old days, man. But yeah, the Earth is round and small, according to Aristotle, and while he doesn't reference the Earth's shape in his book on physics, he uses his theories on elements to prove that the Earth is a round blueberry ready to take on the universe.
Stop! You made me drop a croissant! Why did it fall in there?
Aristotle thought for a bit, like he usually did, and came to the conclusion that things fell toward their natural places. A substance, or object's natural place, is based on its composition. So things made of water would migrate toward the sea or sea level, and something like smoke would go toward the atmosphere since it's air-like. Neat. Aristotle also believed that heavier things fall faster than lighter things, because duh, where's this old man talking about gravity? In Book 4 of Physics. Fun fact about Aristotle's theory on natural places. While it was constantly debated since its birth, the definition of natural places remained the dominant belief of physicists until the beginning of the 17th century.
Before, we said that natural places aren't specific locations, so let's talk about some basic rules of location. These aren't Aristotle's examples. 1. The same place can be occupied at different times by different bodies. Maybe a butterfly was in a sunspot in the morning and a caterpillar came to the same spot at night when the butterfly was gone. 2. An object can occupy more than one thing at different times. Maybe a butterfly was sitting on some dirt and a rock at the same time. 3. A place cannot be identical to the body that occupies it. A butterfly can't sit on itself. Aristotle asks some more philosophical questions about places, like whether or not locations even exist. He defends the existence of places by, again, citing his natural elements, claiming that they all head to their natural place, and that every place has its own potency. For more specific reading on locations, try flipping through Book 4 of Physics. Change. Anyway, Aristotle had something to say about the causes of change. To quote the man himself, we do not have knowledge of a thing until we have grasped its why, that is to say, its cause. So Aristotle came up with these things called the four causes to explain what causes everything to change. Nice! Number 1. Material causes. Material causes are the types of change that are determined by the composition of the changing thing or things. The change happens because the table is made of wood, or because the statue is made of bronze. Number 2. Formal causes. Formal causes are the type of changes that occur because of how the changing thing or things are arranged or shaped. Basically, if something changes formally, is change because of how it looked. Pretty shallow, Aristotle. Number 3. Efficient causes. An agent cause, or the efficient cause of a changing thing, is an agency by which our thing becomes our thing. Like how the efficient cause of a baby is its mother. Actually, no, this is ancient Greece. The efficient cause of a baby is its father. Or like how the efficient cause of a table is its carpenter. In Book 2 of Physics, Aristotle wrote, "There is that which is the primary originator of the change and of its cessation, such as the deliberator who is responsible and the father of the child, and in general the producer of the thing produced and the changer of the thing changed." That's easy to understand. Put as simply as a 10th grader can, efficient causes are based off the creator or bringer about of an object or thing. And for the final causes. The final cause is something's purpose, why it exists in the first place. A seed's final cause might be becoming an adult plant, or a sailboat's final cause might be, sailing? You get it. Where can you read more about the four causes? Try reading Book 2 of Physics, and maybe even dabble a bit into his book on metaphysics.
Coming to B. The four causes aren't the only part of Aristotle's theories on change. There are lots of different ways to describe change, actually. Let's say someone takes guitar lessons and becomes a musician. This is just the beginning of our musical man scenario, so let's give him a name. We'll call him Steve. You can describe the change from the following examples. A. Steve becomes musical. B. Unmusical Steve becomes musical. And C. Unmusical Steve becomes musical Steve. Let's get some definitions in here. The initial object. The subject that goes under the change. In this case, it is the unmusical Steve. The resultant object is a subject that results from the change. In this example, it's the musical Steve. And the persisting object is a subject that stays the same all throughout the situation. In this case, the persisting object is our boy, Steve. Steve is still Steve throughout the change, just with a description, musical, unmusical, all that. Simple and compound. Aristotle notes that, in the musical Steve scenario, we have three simple items, Steve, musical, and unmusical, and two compound items, musical Steve and unmusical Steve. Then we have the subject of the change, which is a thing that undergoes the change and that still remains at the end of the change. In our case, it was the man, the myth, the legend, Steve, remaining. In the beginning, we didn't have either a musical Steve or a musician. At the end, we didn't have either an unmusical Steve or a non-musician. Aristotle insists that we must pay attention to the question, what remains during the situation and what changes? Just a tad more on change, bear with us. Non-substantial change. Back to Mr. Steve, the man of music. The initial object is the unmusical Steve, the resulting object is the musical Steve. Both are compounds, even though they are sometimes described with simple terms, a man or a musician. A substantial change. Aristotle gives us an example. The lack of figure, shape, and order is the contrary, and the bronze, stone, or gold is a subject. He's evidently thinking of a statue. The statue is a compound of matter and form. More about changes like this can be read in Book 1 of Physics. Now that we're finally done talking about causes and change, we're going to change into the end of the video.
Now, Aristotelian physics is much more complex than we have described. I mean, the guy wrote like 8 books on it. But hopefully, our brief overview of his studies provided a broad understanding of Aristotle's theories on physics.